In this example, we'll be finding a possible equation for the function with a graph having the given features with x-intercepts, -4, 0 and 5, 0, a y-intercept at 0, -20, and a vertical asymptote through x equals 1, and a horizontal asymptote through y equals 1. Alright, so let's start with the x-intercepts. X-intercepts are zeros of the function, and the function will be 0 if the numerator becomes 0, since we're dealing with a rational function. So I think we would be looking for a function f of x that has x plus 4 and x minus 5 in the numerator. Because then if you plug in -4, you'll get 0 for y. And if you plug in 5 for x, you'll get 0 for y. Also, we have a y-intercept at -20. So that means that when x is 0, y should become -20. So let's look and see. If I plug in 0 for x here with what I've started, then I'll have +4 times -5, which is -20. So that's a possibility. Seems like we're on the right track so far, but let's see what's happening with the denominator. We have a vertical asymptote at x equals 1. Vertical asymptotes represent restrictions on the domain, values that would make the rational function undefined. So that would mean that I have a factor in my denominator, x minus 1. Because then if I plug in 1 for x, I will get 0 in the denominator, which will make my function undefined, and then it makes sense that I have a vertical asymptote there. Also, if I plug in 0 for x, I will get the -20 in my numerator and -1 in my denominator, which will give me a +20. Okay, well, I don't want a +20. I want a -20, right? So maybe there needs to be a negative in front of the whole thing. That's one way that would solve it, or, make everything work out according to what we have here so far. And then there's also a horizontal asymptote at y equals 1. Now, the only way there would be a horizontal asymptote at y equals 1 is if the numerator and the denominator each had the same degree, and their lead coefficients were the same, so that when you do the ratio, you get 1. Now, if you don't know what I'm referring to, you need to go back to the video where I walked through the textbook and pointed out the theorems and the properties that allow us to be able to figure out what these different types of aspects of a graph mean. And so I'm assuming that you've already seen that, or you've already read the chapter when I'm discussing horizontal asymptotes. I discussed before that we have 3 scenarios with non-vertical asymptotes. Either your degree of your numerator and denominator are the same, and then your horizontal asymptote will be the ratio of the 2 lead coefficients, or you'll have a bottom heavy where your degree in the bottom is higher than your degree in the top, which so far doesn't look like the case, but if that were to happen, we would have a horizontal asymptote at y equals 0. And then the last option is that your top is heavier or higher degree than your bottom, top heavy, by 1, a difference of 1. So this is the case where we have a horizontal asymptote, which means my degree in the top cannot be more than my degree in the bottom. Otherwise, that would be possibly an oblique asymptote, not a horizontal one. So that leads me to realize that, hey, I'm going to need another linear factor down here in the bottom so that both the top and the bottom will have a degree 2. And since I was thinking, well, with this scenario, I would get a -1 in the denominator if I plugged in 0, and that would cause me to have a +20 instead of a -20 like what we want to have. Another way, instead of just putting a negative in front of the whole thing, another way this could be remedied is if this were squared. And that would actually also solve the dilemma of having the same degree in the top and the bottom, so that I could have this horizontal asymptote. So that, I believe, is what the function should look like, right there. So let's see if there's an option that matches what we've come up with here. And this one, x minus 5, x plus 4 over, oh, there you go, there it is, it's the first one. Let's see if the others, this one couldn't be it, remember, because the denominator can't have a degree lesser than the top with this as a horizontal asymptote. This can't be the case because then you would not have the 0 at -4. This would mean that you had a 0 at 1, and that's not one of the zeros that was given. And this one was our winner. Number 7, find a possible equation for the function with the graph. Okay, again, same type of question. So building it again, the x-intercepts, I'm thinking that it's going to be x plus 2 and x minus 4 in the top. The y-intercept has to be -8. We'll get to that in a moment. After we put the vertical asymptote, x minus 1 in the bottom. Right? The horizontal asymptote is 1 again. So that means that the numerator and the denominator have to have the same degree, and the lead coefficient, oh, this is actually a duplicate question, I just realized. That's exactly the same question. No wonder it feels so familiar. But once again, we're going to have to square this, and that should make everything work out right for us. So let's just try. F of 0 would be 0 plus 2 times 0 minus 4, 0 minus 1, quantity squared, so that simplifies to 2 times -4 over -1 squared, which is +1, and that gives you the -8, like right here. So the answer will be this one. Number 8, give the equations of any vertical, horizontal, or oblique asymptotes for this rational function. Easy. The vertical asymptote will be at x equals 5, because that would make the denominator 0. The equation of the horizontal asymptote is, okay, so it's already telling us that we have a horizontal asymptote. It's kind of giving it away. But let's see. Horizontal or oblique, there are 2 possibilities. There's actually 3 possibilities. Either the degree of the top is the same as the degree of the bottom, and then you would have y equals 0 as a horizontal asymptote, or, oh, I said that wrong. I meant to say, for the first option, the degree in the top is less, how should I say this? Shorthand, degree of the numerator will be less than the degree of the denominator. Then you have y equals 0 as your horizontal asymptote, which would be the x-axis. Or you could have another case where you have a horizontal asymptote where the degree of the numerator is the same as the degree of the denominator. And then you would have y equals the coefficient of the denominator or numerator over the coefficient of the denominator. Or you could have the degree of the denominator plus 1 in the top, so that the degree of the numerator is 1 more than the degree of the denominator, and then you would have an oblique or slanted instead of a horizontal asymptote. So which one do we have here? The degree here is 0, the degree down here is 1, so this is bottom heavy, which means it's the first case where we have a horizontal asymptote at y equals 0. I think I can do one more. How long is this video so far? 10 minutes. I think I'll stop there and start a new one.